So alternating current effective value or virtual value of AC. So we know alternating current is varying every instant, and after half cycle its direction is reversed. First half cycle if it is positive, the next half cycle will be negative. So that is AC. So when AC is passed through an element like resistor or anything like that, inductor, capacitor like that, if we take average current, average EMF over one full cycle, that will be zero. Average value of one cycle of AC is zero because first half cycle positive, next half cycle negative. So average when you take it will be zero. So what we do is we have to find out a corresponding value of AC that must be in DC. That means steady current. That must be a steady current. So it is that steady current which produces the same effect as is done by the AC when it is passed through a resistor for the same time through the same resistor. So what is the RMS value or virtual value of AC? It is considered as a steady value. We know AC is a varying value. So virtual value is considered as a steady value which will produce the same effect when it is passed through a resistor. It will produce the same heating effect as is done by the AC when it is sent through the resistor for the same time period. So virtual value of AC is considered as steady value of AC. So the magnitude of a steady value, that is considered as DC value. The magnitude of the DC which produces the same heating effect in a resistor as that of AC, that is known as the effective value or virtual value or RMS value. Like that, all are same meaning. RMS value, virtual value, effective value, all meaning is same. So let alternating current. See instantaneous value of current. We know the equation for EMF E equal to E0 sin omega t. That in generator, while describing that, we got the formula for EMF, induced EMF. E is equal to E0 sin omega t. Corresponding to that, we get I equal to I0 sin omega t. How will you get I? E by R, resistance of the circuit, that will give I. So alternating current I equal to I0 sin omega t, if it is written, this I means it is an instantaneous value of current. At a time t, because every instant current is magnitude is changing. At that particular instant we are taking I equal to I0. I0 is the maximum value of current. I0 sin omega t. So that an alternating current I equal to I0 sin omega t is sent through a resistor of resistance R in a small time dt. The amount of heat produced is equal to, we can find out the heat produced. What is the formula? H equal to I squared RT. That is the formula. H equal to I squared RT. So the small heating effect produced in a resistor R when AC is sent through the resistor for a small time dt. The heating effect formula I squared RT. So here we find, as it is AC, we find for a small time interval what is the small heating effect produced when AC is sent through the resistor. So dH equal to I square R dt. What is I here? AC current. So I equal to I0 sin omega t. So we have to square it. So I0 square sin square omega t. Then this R is there. Then this dt is also there. So instead of I, what we have to write? AC current is sent. So that formula you have to write. I equal to I0 sin omega t. Therefore I square equal to I0 square sin square omega t into R into dt. This is the small heating effect produced. Therefore, total amount of heat produced in the resistor in one complete cycle of AC. One cycle means time period becomes 0 to t. So, one cycle of AC. So, AC diagram we have seen. One cycle means 0 then 90-degree rotating, it becomes EMF maximum, then 0, again negative maximum, then 0. That is one cycle of AC. Time period changes from 0, T by 4, T by 2, T by 4, and then T. Time period for T by 4, that is T. Time period, one cycle of AC, one rotation of the coil is over. That means one cycle of rotation. The time period taken is 0 to capital T, that is the time period for one rotation of the coil. Therefore, total amount heat will you calculate integrating the above expression from 0 to T. So, I0 square, that I0 is the peak value, that is constant, so it's taken outside. I0 square, then R also, that resistance is constant, it is constant, not varying, so R is taken outside. Then integral 0 to T sin square omega T dt. Then sin square omega T, I think you are mathematics students, so you are knowing it can be written in this form. Sin square omega T equal to 1 minus cos 2 omega T by 2. 1 minus cos 2 omega T by 2. Sin square omega T can be written in this form into dt. Then we split each term. 2 you can take outside. I0 square R by 2 into integral 1 into dt, that is dt, minus second term, integral 0 to t cos 2 omega t dt. So we split the two terms. Then next step, integration is done. Integral dt t, integral dt t, apply the limit 0 to capital T minus integral cos 2 omega t sin 2 omega t, and again you have to integrate this part 2 omega t. So what is it? 2 omega it becomes. So divide here. In differentiation we multiply with that factor, but in integration we divide with that factor 2 omega. Differentiation. Have you studied differentiation in maths? Namrata? Amrata? Namrata? Namrata, not 10-7. Abhirami? Abhirami?
Yes, teacher.
Did you study differentiation in mathematics? That portion is taken by the teacher. Differentiation? No? Yes or no? No.
Yes, teacher.
No.
Yes.
Yes or no?
Yes.
Yes, okay, okay. So then integration is taken? Integration?
Integration എടുത്തിട്ടില്ല.
Okay, okay. Only difference. Okay.
Ah.
So here we are integrating that. Differentiation, you know, when you differentiate this, we get a function minus sin 2 omega t, and we multiply with 2 omega. Just like that. Here integration, this is integration. Integral cos 2 omega t will be sin 2 omega t, and again you have to differentiate this factor and divide with that. That is by 2 omega. Into 2 omega ki pagaram by 2 omega integration. Then limit 0 to capital T. Then I0 square R by 2 into upper limit minus lower limit T minus 0 minus 1 by 2 omega is taken outside. Then sin 2 omega T. What is omega? Omega is 2 pi by 2. What is omega T? Capital T it becomes, because by giving upper limit we are getting, lower limit is 0. By giving upper limit we get capital T here. So 2 omega T, capital T. So omega T equal to 2 pi. So we get sin 2 into 2 pi. What is 2 into 2 pi? 4 pi. What is sin 4 pi? 0. So this term is vanished now, because sin 4 pi is 0. So this term you can neglect because it is 0. Then only this term remains. So
which are others basically.
Others. Okay. Okay, with that, all the 38 will be there. Very good. Wonderful. Very happy to see all the 38 are here. Okay. Here, I0 square R by 2 into capital T minus 0. Other term becomes 0. Then what we get? I0 square RT by 2. So this is the heating effect produced when AC is sent through a resistor for one cycle of AC is sent through the resistor. Understood. Then if RMS value corresponding to this AC, we are finding a steady value of it. Steady value. Corresponding to this AC, we find a steady value of AC. That also will produce the same heating effect in the resistor. So, that will also produce. So what is the actual value of AC or steady value? That is the steady value of AC, which will give the same heating effect as is done by the AC for the same time period through the same resistor. So if we take IV is the virtual value of AC, that is sent through the resistor of resistance R for the time T. So what is the heating effect produced? What is the formula for heating effect? I square R T. Here it is IV is sent. So IV square R into T. That is the heating effect produced. When virtual value of AC is sent. Virtual value of AC is sent. Okay. Akshay. So if IV is the virtual value of AC send, virtual value means steady value, corresponding to that varying value of AC, equivalent to that varying value of AC, we take one steady value, that is IV here. So that produces the same heat effect in the same resistor, same time period. Okay, so H equal to IV square RT, we can write. Then we can equate both the equation. Both are producing the same heating effect. So we can equate them. IV square RT equal to I0 square RT by 2. RT cancel, we get IV equal to I0 by root 2. I0 is the peak value. I0 by root 2 and 1 by root 2 is 0.707. 1 by root 2. When you do it, root 2 value. What is the value of root 2? 1.414. So when you do that calculation, we get 0.707 I0. This equation is very important for doing problems and all, because always 230 volt is applied. That means that is the virtual value of voltage. So always we need the virtual value of current and virtual value of EMF. So this relation also you should know. Virtual value and the maximum value of AC. Virtual value of AC and the maximum, like a peak value of AC. That is the relation connecting IV equal to I0 by root 2. Similarly, EV equal to E0 by root 2. What is E0? It is the maximum value of EMF. What is I0? Maximum value of current. So, it is always less than. See, IV is always less than I0. That means I0 is the peak value. I0 by root 2 is IV. So IV is always less than the peak value. Okay. So always remember this formula, derivation you have to study, write and study all derivations. This time I told you now, exam, it is not a multiple choice questions only. All type of questions will be there. Prepare for that. Next, so virtual value of AC, we found the relation connecting virtual value and the maximum value of current, virtual value of EMF.
Teacher,
Yes.
teacher doubt. ടീച്ചർ ലാസ്റ്റ് പേജിലത്തെ അടിയിലത്തെ ഭാഗം ഒന്നും കൂടി പറഞ്ഞുതരോ?
This one?
ലാസ്റ്റ് കഴിഞ്ഞ പേജിലത്തെ പേജ് നമ്പർ 2-ലത്തെ.
Okay. Last line. page 2. Okay. Integration ആണോ?
ആ ഭാഗം ഒന്ന് ക്ലിയർ ആയില്ലേ എനിക്ക്.
ഇല്ല. Okay. This integration step. This one, sin square omega t can be written as 1
അല്ല
minus.
ടീച്ചർ ലാസ്റ്റ് ഭാഗം പറഞ്ഞു തന്നാ മതി.
മതില്ലേ? Okay. This one.
അല്ല നമ്മള് ഇഫ് ആ വേർഡ്സ് എഴുതിയിട്ടില്ലേ, ഇഫ്
words.
ഇക്വൽസ് വാല്യൂ ആ ഭാഗം.
Okay. So when AC is sent through the resistor for a time period T, capital T, this is the heating effect produced. Okay. Then we find out a value, steady value corresponding to the AC. We find out a steady value. That is known as effective value or virtual value of AC, and that is always steady. So we need not go for all these variation because current is not varying. We no need to do all these steps. These steps we are doing because it is AC current. Every instant it is changing. So we have to first find out the small heating effect produced for a small time dt, because small time only that current remains same. That is why we integrate and do all these steps to find out the heating energy. But virtual value we consider as a steady value. It is just like DC value. And virtual IV is the virtual value equivalent to this this AC current. We send a steady current. If we send a steady current equivalent to that, that will produce also the same heating effect. So according definition is saying like that. Virtual value of AC is that steady value of AC, which will produce the same heating effect as is done by the AC when it is passed through the resistor for the same time period. So we consider IV. IV is the virtual value of AC. That is so you have to consider that is a steady value. You have to imagine that is the steady value equivalent to that AC sent through that resistor. So if IV is the steady value of AC, that is steady value corresponding to that AC which is sent through the resistor resistance are for a time t. Same time we are sending. Same resistor is taken. What is sent? Virtual value of AC, steady value of AC is sent. Then what is the heating effect produced? General formula H equal to I squared RT. That is the general formula, heat energy produced. So if IV is the current sent, instead of I we have to write IV square RT. That's all. IV square RT. I think it is clear now.
ടീച്ചർ ക്ലിയർ ആയി.
Okay. Like that you can ask doubt, then only I can clear. Okay, heating effect produced equal to IV square RT. So according to the definition, both will produce the same heating effect. So we can equate them. Same resistor, same time period, we send IV sent, and similar equivalent to that IV and AC is sent. Both produces the same heating effect. So we can equate them. So on equating, RT get cancelled, we get IV equal to I0 by root 2. So that is the relation connecting virtual value and peak value. Peak value is also known as maximum value of current, I0. I equal to I0 sin omega t. I0 is the maximum value of current. Similarly, EV equal to E0 by root 2. Then comes the other derivation, AC circuit containing resistance only. So individually we are studying when AC is sent through a resistor, when AC is sent through an inductor, when AC is sent through a capacitor, what behavior it shows, that we have to study. And when all the elements are together, what it shows, what behavior it shows, all those things we have to study now. So first one, resistor, it's a very simple derivation. When AC is sent through a resistor, we know resistor, inductor, capacitor, all these elements, all these devices reduce current. Resistance you have studied DC. In DC also, to reduce current we use resistor, isn't it? Similarly, inductor also can be used to decrease or reduce current. Capacitor also can be used to reduce current. And its behavior will be different. All these elements, so different behavior to AC. That is what we have to study now. So when AC is sent through a resistor, first we have to consider suppose E equal to E0 sin omega t is the alternating EMF supplied to a resistor. Then what is the current? EMF is given. It is sent through a resistor. And figure will be that. Yes. See, this is the figure. So a resistor and the AC is connected. So think about AC now. And current electricity we have studied DC only. Here it is AC. AC symbol is this. And the equation is this: E equal to EMF applied, EMF supplied or applied. That's equal to external to the resistor, and EMF is applied. E equal to, what's the formula? Applied EMF. E equal to capital E. Small e for induced EMF. Capital E, applied EMF. So we have the alternating source is provided here. Generator gives us alternating current. In our house also, we are getting the alternating current. And in order to convert AC into DC, that rectifiers and in lab and all we are using that means adapter, for charging mobile and all. That is DC. Adapter convert AC into DC. Charging and all we use DC current. But all the other devices, that means iron box, everything, we use AC current. So certain devices use AC and certain devices use DC current. Okay. So AC has to be, some cases we have to convert into DC. For that rectifiers are there, and then eliminators are there that will convert AC to DC. And that also you have to study in one last chapter, that is semiconductor chapter. You are studying how to convert AC to DC. Okay, now you are studying about AC. Okay. So here AC is connected to a resistor, and how will you calculate the current? You can see how you calculate the current. I equal to E0 by R, E0 sin omega t by R. You can see. AC circuit contain resistance only. First, what you have to write? First, you have to draw figure. Resistor and an AC source. EMF applied. E equal to 0 sin omega t. What is the corresponding current in the circuit? So I we get by, see, I into R, that is the voltage. I into R is the voltage across the resistor. So I into R is the EMF. EMF applied will appear as the voltage across the resistor. So I into R is the EMF applied. EMF applied is also equal to 0 sin omega t. So what is I from that equation? Take R to this side. So EMF by, according to Ohm's law, the total EMF by resistance, that will give the current. So E0 by R into sin omega t. E0 sin omega t by R. What is, this is peak value of EMF. Peak value of EMF by the resistance will give the peak value of current or maximum value of current. So we get I equal to I0 sin omega. This is according to Ohm's law. This term E0 by R is I0. This is maximum value. So we get maximum value of current. So I equal to I0 sin omega t. You compare equation 1 and 2. This is equation 1 and 2. You see, E equal to E0 sin omega t. The corresponding current that we get when AC is passed through a resistor, the equation for current is I equal to I0 sin omega. And here both are in same phase. This is omega t and this is also omega t. We are not at all adding something or subtracting something from this. If we get an equation I omega t plus pi by 2 or minus pi by 2 or plus pi minus pi, like that if we are getting, then we can say there is a phase difference. Here both are omega t. This is omega t and this is also omega t. And with that angle, we are not at all adding or subtracting anything from this. So we can say both are in same phase. So when AC is sent through a resistor, EMF and current are in same phase. That is a very important result. So I0 is E0 by R is the maximum value of current. From 1 and 2, we find that E and I are in same phase. So same phase, how can you tell? You have to find out. With omega t, is there anything plus or minus when we get current from it? No. So see, inductor and capacitor, you will see that something we are adding or subtracting from that. That means they will not be in same phase. But in resistor, we got they are in same phase. Therefore, in an AC circuit, current and resistance are in same phase. And there is a phasor diagram which is very important. Along with the question, always ask, draw the phasor diagram corresponding to this behavior when AC is sent through a resistor. Phasor diagram. This is the phasor diagram. See, phasor diagram. Phasor is a vector which rotates about the origin with an angular speed omega as shown in figure. So phasor is a vector quantity. See, this current and EMF all are now expressed as vectors. So in order to simplify that, we have taken all these EMF and current are taken vectors. And you know, a phasor is a vector. So all these are vectors and we are drawing the phasor diagram. This diagram is known as phasor diagram. So we should show the phase with the phase of the voltage and current. So phasor is a vector which rotates about the origin. This is the origin. Which rotates about the origin with an angular speed omega as shown in figure. So that vector is rotated with an angular speed omega from the origin. In this diagram, peak values of AC I0 and alternating EMF E0 are represented by arrows called phases. So in this diagram, this vector I0 and this vector E0 both are vector quantities. Both are vector quantities. So we are representing all these E0, I0 which are the vectors in this phasor diagram. So if they are in same phase, they see omega t, sin omega t is there, E equal to 0 sin omega t, I equal to I0 sin omega t. So when it is started from the origin and with an angular velocity, if it is that vector is rotated, it is rotated with anti-clockwise direction, always rotated in anti-clockwise is taken as positive and clockwise is taken as negative. So here the vector is rotated in anti-clockwise direction and the phase is omega t. E equal to 0 sin omega t. I equal to 0 sin omega t. Omega t is the phase. So phase angle we are showing here. So this is x-axis and this is y-axis. So along the x-axis omega t is taken, time is taken and EMF is taken along the y-axis and omega t, that is the phase angle for the EMF and current. So it is rotated anti-clockwise direction. So as this is new to you, I am explaining all this. Actually, exam they will not ask what is phasor like that. How you represent, you have to draw this figure, that's all. But you should be, in the beginning, you should know everything. Why this diagram is drawn. Just by seeing that, you should be able to tell E0 and I0 are in the same phase. Omega t is the phase. And you know why I0 is marked less length, the length of the I0 vector is small, because I0 is E0 by R. Anyway, that will be less. E0, we are dividing E0 by the resistance of the circuit. E0 by the resistance of the circuit. So magnitude of I0 will be less. That's why it is represented with a smaller length vector. So I0 is smaller length vector and E0 is the greater length vector and they are in same phase. So we represent along the same line. So by seeing this diagram, you should be able to explain all these factors. Actually, exam, they will ask only diagram. If you draw it with the proper arrow marks and all, that's enough. But when you in the beginning, you should know everything. What is a phasor? Phasor is a vector which rotates about the origin with an angular speed omega as shown in figure. In this diagram, peak value of AC I0 and alternating EMF E0 are represented by arrows called phasors. So, this vector I0 and vector E0 are phasors. They are inclined to the horizontal axis at an angle omega t. See, they are inclined to the horizontal, this is the horizontal axis, x-axis. Inclined to the horizontal axis with an angle omega t. Then angle omega t, yes, omega t, and rotate in the anti-clockwise direction. The vectors or the phasors are rotated in anti-clockwise direction. The length of the arrow represents the maximum value of the quantity. You see in the figure, length of the arrow. You see, when you extend this to this side, this length of the arrow is giving I0. Here, on the y-axis, we are getting, see, just extend this and take the projection of this value on y-axis. That will give the peak value at this point, peak value of current. And here, this is the peak value of EMF, this is the peak values, maximum values. The length of the arrow represents maximum value of the quantity, that is vector E0 and vector I0. Length of the arrow, I told you now, I0 is having less length compared to E0. Why? Because I0 is E0 by R. Projection of the arrows on any axis represents the instantaneous value of the quantity. How will you get instantaneous value? Instantaneous, see, from here at this particular instant, what is the current? This is time, and here we mark time. At this particular instant, what is the current? You just take the projection of that. Projection. So, ഇവിടെ നിന്ന് ഒരു ലൈൻ വരയ്ക്കുക, perpendicular, അവിടെ നിന്ന് ഇങ്ങോട്ടൊരു ലൈൻ വരയ്ക്കുക. അപ്പോൾ projection. Projection means the drawing perpendicular from that point. So, corresponding to this time, we get a current or an EMF. Here you can take E or I, both use the, if it is E and T graph, it will give E. If an I and T graph, we will get I and T at a particular instant. Every instant the current magnitude is changing and this is the maximum value, peak value. In between we are getting at different instants of time, what is the EMF that we get. How? By drawing a projection to the axis. Sine curve, we take the projection on y-axis. Cosine curve is there. Cosine curve, we take the projection on x-axis. Here we represent it with the sine curve. This is sine curve. This is sine curve. Sine curve. This is the form of sine curve. Here we use that only. Okay. Projection of the arrows on any axis represents instantaneous values of the quantity. In sine form, projection is taken along the vertical axis, and in cosine curve, the projection is taken along horizontal axis, horizontal x-axis. Okay. So, phasor diagram I will show you again because that is important when AC is see among the three. When AC is sent through an inductor, AC is sent through a capacitor. When AC is sent through, this is among the three. This is the simplest one. When AC is sent through a resistor. No derivation, nothing is there, just we divide E0, E equal to 0 sin omega t divided by R, we get I equal to 0 sin omega t. Very simple only, and diagram also very simple. Both you have to show in the same phase. Omega t is the phase angle from this x-axis, and this gives I0, length of the arrow gives the magnitude and the projection onto the y-axis. Yes.
ഈ ഡയഗ്രം വരച്ചു പഠിക്കണോ?
വരച്ചു പഠിക്കണം കേട്ടോ. വരയ്ക്കുക, അതാണ് ടീച്ചർ ഇത്രയും എക്സ്പ്ലെയിൻ ചെയ്യുന്നത്. അപ്പൊ when AC is sent through a resistor, what is the corresponding current? Question അങ്ങനെ ആയിരിക്കും. Show that they are in the same phase and draw the phasor diagram. അങ്ങനെയൊക്കെ ആയിരിക്കും ക്വസ്റ്റ്യൻ വരിക. അപ്പൊ phasor diagram വരയ്ക്കണം. അപ്പൊ ഇതൊന്നും എഴുതേണ്ട ആവശ്യമില്ല, നമ്മൾ ജസ്റ്റ് വരച്ചാൽ മതി. ഇത് ടീച്ചറെ എക്സ്പ്ലെയിൻ ചെയ്യുന്നത് എന്താണെന്ന് വെച്ചാൽ നമുക്ക് എല്ലാത്തിനും ഇത് ആവശ്യമാണ്, എങ്ങനെയാണ് വരച്ചതെന്നുള്ള അറിയാം. ഡ്രോ ഫേസർ ഡയഗ്രം എന്ന് പറയുമ്പോൾ നിങ്ങൾ ഇങ്ങനെ ഡയഗ്രാം വരച്ച് കാണിച്ചാൽ ഓക്കെ. നെക്സ്റ്റ് Now the verb form also is there. Verb form. For knowing the verb form, that. Sorry.
ടീച്ചർ ഒരു ഡൗട്ട് ടീച്ചർ
Okay.
ടീച്ചർ എന്തോ പറഞ്ഞില്ലേ സൈനും കോസും ആണെങ്കിൽ എന്തോ വ്യത്യാസം വരുന്നു
EMF അല്ലേ?
ടീച്ചർ അതൊന്നും കൂടെ പറയൂ
AC അല്ലേ? AC. Okay. ഇത് പറഞ്ഞുതരാം കേട്ടോ.
അതല്ല ടീച്ചർ ഇപ്പൊ തന്നെ ടീച്ചർ പറഞ്ഞില്ല ഗ്രാഫിൽ
ഓക്കെ. അതായത് കൊസൈൻ കർവ് നമ്മളിപ്പോൾ ഇവിടെ പഠിക്കുന്നില്ല. കൊസൈൻ കർവ് എന്ന് പറയുമ്പോൾ അത് വേറെ തരത്തിലാണ് വരിക. ഇങ്ങനെ വരിക. ആദ്യം മാക്സിമം വന്നിട്ട് ഇങ്ങനെ വരിക. അങ്ങനെ വരും കൊസൈൻ കർവ്. കൊസൈൻ കർവ് എടുക്കുമ്പോൾ നമ്മൾ എക്സ് ആക്സിലേക്കാണ് പ്രൊജക്ഷൻ എടുക്കാവുന്നത്. ഇത് നമ്മൾ വൈ ആക്സിലേക്കല്ലേ എടുത്തത്? കണ്ട വൈ ആക്സിലേക്ക് എടുക്കുന്നത് കണ്ട കൊസൈൻ കർവ് ആകുമ്പോൾ അത് എക്സ് ആക്സിലേക്കാണ് എടുക്കുക. അതാണ് പറഞ്ഞത്. അപ്പം നമ്മളിപ്പോൾ ഇത് പഠിച്ചാൽ മതി, സൈൻ കർവിൻ്റെ പഠിച്ചാൽ മതി കേട്ടോ. കൊസൈൻ കർവ് ആകുമ്പോൾ ആക്സിലും പറഞ്ഞതാണ്. പക്ഷെ നമ്മളിവിടെ പഠിക്കുന്നത് മുഴുവൻ സൈൻ കർവാണ് കേട്ടോ. കൊസൈൻ കർവ് ആണെങ്കിൽ അത് എക്സ് ആക്സിലേക്കാണ് പ്രൊജക്ഷൻ എടുക്കാന്നാണ് പറഞ്ഞത്. അപ്പോൾ ഫേസർ ഡയഗ്രാം വരയ്ക്കാൻ പഠിച്ചു. ഫോർമുല E=0 sin omega t, കറസ്പോണ്ടിങ് കറണ്ട് I=0 sin omega t പഠിച്ചു. ഇനി ഈ വേവ് ഫോം ആണ് എങ്ങനെ കിട്ടിയെന്നുള്ളതാണ് പഠിക്കേണ്ടത്. വേവ് ഫോമിൻ്റെ ഇക്വേഷൻസ് ദിസ് കോളം അതിനാണ് വേവ് ഫോം വരയ്ക്കാനുണ്ട്. ഈ ഒമേഗ ടി ആണ് ഫേസ് ഓൺലി 5 minutes. ഒമേഗ ടി ആണ് ഫേസ് ആംഗിൾ. E=0 sin omega t, I=I0 sin omega t. അപ്പോൾ E=0 sin omega t, omega t 0 ആകുമ്പോൾ ഇനീഷ്യൽ പൊസിഷൻ AC we know AC 0, maximum, positive maximum, again 0, then negative maximum, again 0. That is actually AC. In that 0, T/2, dt/4, then T, like that time period goes. So omega t, when it is the phase angle, what is the EMF? E=0 sin omega t. Omega t 0 by initial position 0. അപ്പോൾ ബോത്ത് ആർ സീറോസ്. E and I are zeros. അപ്പോൾ അതാണ് ആ ഗ്രാഫിൽ നമ്മൾ കണ്ടത്. ഫസ്റ്റ് പൊസിഷൻ ഫസ്റ്റ് വി ക്യാൻ ഡിസ്കസ് ദിസ്, ദെൻ വി ക്യാൻ ഷോ ദ graphical representation of the sign, this EMF and current. Then pi/2, 90 degree rotating. So here when angle is 90 degree, omega t is 90. അതായത് 90 ഡിഗ്രി വരുമ്പോൾ 1/4 ഓഫ് ദ റൊട്ടേഷൻ ആണ് 90. സോ ഹിയർ 90 വരുമ്പോൾ എന്ത് വരും? സൈൻ 90 വരും. അപ്പോൾ ഇവിടെ എന്ത് വരും? E0 സൈൻ 90 1. അപ്പോൾ ഇക്ക് E0 കിട്ടി. സിമിലർലി ഐക്ക് I0 കിട്ടി. ഇനി പൈ ആകുമ്പോഴോ ഒമേഗ ടി പൈ ആയി കഴിഞ്ഞാലോ ഒമേഗ ടി പൈ what we get 0 again 0 sin pi sin 180 0, here also sin 180 0. അപ്പോൾ ഒരേപോലെയാണ് വേരി ചെയ്യുന്നത് കണ്ട. ഇത് പീക്ക് വാല്യൂ എടുക്കുമ്പോൾ ഇതിൻ്റെ പീക്ക് വാല്യൂ, ഇത് 0 ആകുമ്പോൾ ഇതിന് 0. ഇനി നെഗറ്റീവ് മാക്സിമം 3π/2. ഇവിടെ സൈൻ 3π/2. ഒമേഗ ടിക്ക് പകരം എന്ത് കൊടുക്കണം? 3π/2. അതായത് എത്ര വരും? ആംഗിൾ 270 അല്ലേ? ഇത് വരുമ്പോൾ 360 വരും. ഇത് 270. π/2 pi 270 and this is 360. 270 വരുമ്പോൾ മൈനസ് വരും. 90ക്ക് പ്ലസ് ആണ് വന്നത്. 270 വരുമ്പോൾ മൈനസ് വരും. മൈനസ് E0 വരും. ഇവിടെ അത് വരും മൈനസ് വന്നു. അപ്പോൾ ഒരേപോലെയാണ് വേരി ചെയ്യുന്നത്. പക്ഷെ മാഗ്നിറ്റ്യൂഡ് കറണ്ടിൻ്റെ എപ്പോഴും കുറവായിരിക്കും. I0=E0/R. സിമിലർലി 2π ആയപ്പോൾ വീണ്ടും 0, E=0, I=0. അപ്പോൾ ഒരേപോലെയാണ് കറണ്ടും വോൾട്ടേജും വേരി ചെയ്തുകൊണ്ടിരിക്കുന്നത്. ദേ ആർ ഇൻ സെയിം ഫേസ്, ബട്ട് മാഗ്നിറ്റ്യൂഡ് ഓഫ് കറണ്ട് ഈസ് ലെസ് ദാൻ ദ EMF ബിക്കോസ് I0 is E0/R. So we can go to that diagram. It's like graphical representation. See this one.